All right, everybody. Hello and welcome to the Chapter 1 review for our first chapter test of the CC3 course. All right, so here are learning targets for this chapter. Notice we do have 8 review learning targets, which means we have 4 new learning targets that we just learned this last week. And here we have learning target 1. I can solve problems using a variety of problem-solving strategies. Ooh, I skipped over the quick guidelines. So just remember that this video is to help you, and so please pause the video and attempt the problems before you watch me complete them, and show all of your steps just like you're taking a test, all right? All of your work. That means every single step. And then this is a resource to help you, okay? So please don't mindlessly copy. Really use it to help you prepare for the test. All right, we have our learning target number 1. Here we have Ralph and Alphonse, and they're shooting marbles. Ralph has 6 more marbles than Alphonse, and they have a total of 50 marbles. How many marbles does each of them have? All right, so here we got to set up an equation, and we know that an equation is going to be something equal to something. Well, here I'm going to have my total on one side of the equation, which is 50 marbles, and then I have to think about how can I represent what Alphonse and Ralph have. So I'm going to use a variable a for Alphonse, and Ralph over here, he has 6 more marbles than Alphonse, and so I'm going to do Alphonse marbles plus 6. So if I write that out, I have Ralph here, a plus 6, and then I have Alphonse's marbles, which is just a, and we set it equal to our total of 50. So now we want to get a by itself, and so the first thing I want to do is get rid of that plus 6 by subtracting. So I'm going to subtract the other side of my equation too, right? It's like a scale. So then I have 44 on this side, and then I still have a plus a on the other side of the equation. So let's say I have a plus a, and it's an apple plus an apple. Well, then I would have 2 apples. So I have 2a equals 44. And here it's saying twice of what Alphonse has, or double what Alphonse has. And so the opposite of multiplying, because I want to get a by itself, would be to divide by 2. So if I divide 44 by 2, I'm going to get 22. And 2a divided by 2 is going to leave me with just a, right? This 2 and this 2 would cancel out. So here we have a equals 22. Well, now let's think about what that a is telling us. We said earlier that a is representing the number of marbles that Alphonse has, and so Alphonse has 22 marbles. And then if we take a look at what his friend has, Ralph, we could use an R for Ralph. Ralph would have what 50 minus 22 would be, which would be 28. So Ralph has 28, Alphonse has 22. Did we answer the question? Yes, we did. How many do each of them have? 28 and 22. All right, I can interpret graphs. So examine the graph below and write a brief story that describes the information in the graph. Include a statement explaining what the point of intersection represents. Okay, well, intersection, I know that's like when 2 roads meet, where they intersect, come together. And so here, this would be my point of intersection where the 2 lines meet. So here we're looking at Bartville, which is represented by this line here, and Lisa Town, which I'll do in orange. And so let's take a look at what this graph is saying. First, we have our x-axis, which is the time. And so as the years progress, as time goes on, this is what is happening to the snowfall, right? That's what our y is, snowfall in inches. And so if we're looking at this trend here of Bartville did not have a lot of snowfall to start, but Bartville has been gaining snowfall in recent years. Lisa Town has not had snowfall in recent years. And so what does that point of intersection tell us based off of our story? Well, it tells us that Bartville now has more snowfall all time. So like in the history of snowfall based off this graph, Bartville has taken the lead because Lisa Town hasn't really had any snowfall. All right, so that point of intersection is like when Bartville took over as the leader and he's like, eat my shorts, man. Makes sense if you watch The Simpsons, doesn't if you don't. So here we're looking at another graph. This time it's age. That's our Y. So as you go up, that's going to be the older you get. And so here the oldest people are going to be A and C. And next we're looking at the x-axis, which is the height. And that's going to be as you go to the right. C and D are going to be the tallest, or you're going to get taller. So who are the older students? Well, we have them circled in blue there. That's going to be students A and C. Who are the shorter students? Well, it's going to be the ones that aren't taller. And so that's going to be A and B, the ones that aren't circled. And then who is the taller and older student? Well, it's going to be where we have our little intersection here between our taller and older students. And that's going to be student C. All right, now we're looking at proportionalities here. Proportional relationships. So here we're looking at first a table. We'll label it A since it doesn't have a letter. And here we have our X and Y values. And we can think about this as ordered pairs. We just don't see them on the graphs like we do here in this table, right? We haven't graphed them yet. But if we were to graph them, would it be proportional? Would it make that straight line? And so here we're looking for a constant rate. You might even hear constant rate of proportionality. And basically that's just saying that our X is going up by a constant number each time and our Y is going up by a constant number each time. And they don't need to be the same numbers. All right, for example, let's take a look here at our X. Our X is going up by 1 each time. And then our Y is going up, or down rather, by 3 each time. But since our X is going up by a constant number and our Y is going up at a constant rate as well, this is going to be proportional. In other words, let's say I took my Y and put it over my X. So here I'm going to take -3 for my Y and put it over 1, my X. Is that proportional or equivalent to -12 as my Y over 4, the other ordered pair? You see what I did here? I took this ordered pair right here, and then I took this ordered pair down here, and I put the Y's on top, X's on bottom, and you'll see that if you were to multiply the numerator by 4 and the denominator by 4, it works out. -3 multiplied by 4 gives you -12. 1 multiplied by 4 gives you 4. So these are proportional, or you might even say equivalent. All right, so looking at the next one, does our X go up by the same each time? Yeah, it goes up by 1 each time. But then as we take a look at our y, I don't think we really see that pattern, right? We're going from -6 to -5, -5 to -3. So yeah, we're not going to have that constant rate of proportionality, meaning there isn't a number that you can multiply -1 by to get to 3 that you can also multiply -6 by to get to 4. All right, next we're looking at the graphs. And so here we do have a straight line. And so that tells me right away that this is going to be a proportional relationship. If we want to take a deeper look into why that is, well, let's just take a look at the trend here. So I'm starting at this point right here. And let's say I go over 1, then I go down 2, over 1, down 2, over 1, down 2. And so you can think about this as if our y is on top, we're going down 2, and then we're going over 1 every single time. All right? Could do this forever. And so then we're going to take a look at the next graph. And here we're going up again at a constant rate. We're going to go up 2 over 3, up 2 over 3, up 2 over 3. And every time we're going to hit a point that's on that line. So in this case, it would be up 2 over 3. And this is for graph D. All right, so yes, we could know just by looking at them because they're straight lines. We said no, yes. And then we have this one here, not a straight line, right? Not even close. It looks like it goes way up and then it kind of levels off and then goes up again. So here that's going to be no. Don't even need numbers. All right, looking at the next slide here. Dylan makes $42 for 6 hours of babysitting. Jessica makes $56 for 8 hours of babysitting. Are they paid proportionally? All right, I'm going to take my beautiful red here, and that's going to represent Dylan. And so he's making $42 every 6 hours. So here we want to get this as a unit rate. So I'm going to put it over 1 hour. And so I had to divide my denominator by 6, which means I have to divide my top number by 6 as well. 42 divided by 6 gives me 7. That's $7 per 1 hour, which is my unit rate, $7 per hour. Now we're going to take a look at Jessica in a different color, maybe yellow, a little bit of yellow. And she is making $56 in 8 hours. So here again, we want to get it over 1 hour because that's going to give us our unit rate. So we had to do 8 divided by 8 to get to 1. So we do 56 divided by 8 as well. That gives us $7 per 1 hour. And so, yes. And here's our reason. They both make $7 per hour. So we could say same unit rate. So obviously proportions are pretty cool because then we get to realize, all right, cool. If we have a job where we make $7 per hour, I'm going to make 56 buckaroonies in a long night of babysitting. Good deal. All right, now we're looking at learning target 4, using proportional relationships to solve problems. So here I have a missing value, x. And okay, I want to take a look at what do I have to multiply my numerator by to get to 10. In this case, 5 times 2 gives me 10. So I need to multiply 7 by 2. And that's going to give me 14. Nice and easy. Awesome. Now we're looking at this one here. It's a little bit more difficult by the looks of it because we can't just hop from 9 to 25 by multiplying a nice whole number. So here I'm going to do 25 divided by 9 to figure out what I had to multiply by. And that gives me 2.7 repeating. Draw my little line on top to show repeating. So I'm going to multiply my 3 by 2.7 repeating as well. And that gives me x equals 8.3 repeating, or 8 1/3. So that's what x would give me. All right, now we're looking at C. Stephen can deliver 14 newspapers in 20 minutes. Speedy. I love it. So then the question is, if he can do 14 newspapers in 20 minutes, that's our ratio, how many hours will it take him to deliver 131 papers? Okay, so right away, I am seeing that we jump from 20 minutes to hours, and so I'm going to have to remember that for later. Little note up here, convert from minutes to hours. But first, we got to figure out how many minutes, right? Can't just skip a step. So we're going to set this equal to 131 newspapers. And we're trying to figure out if he can do 14 newspapers in 20 minutes. It would take him how long to do 131 newspapers? So here, I like to do cross multiplication. All right, you could find the unit rate, but I'm going to go ahead and cross multiply. So I'm going to do 131 times 20 and 14 times x to give me a little bit of algebra here. And my equation to represent that would be 14x equals what 131 multiplied by 20 is. And that is 2,620. And now I want to get x by itself. So what do I need to do here to get x by itself? Well, it's saying 14 times x. So the opposite of multiplying would undo what I have here, and that'd be to divide by 14. So I need to do that to both sides. Balance out the old scale. And 2620 divided by 14, that's going to give me 187.14. And so that is going to be the minutes it would take Stephen. But now I want to convert this into my hours, right? I have my little note there at the top. Can't forget to do that. So minutes to hours, I got to divide by 60 because there are 60 minutes in 1 hour. And that gives me a wicked decimal of 3 119. So 3 hours, and can't find the exact minutes here, but it would be close to, let's see, it's about a tenth, maybe like 7 minutes, 3 hours and 6 or 7 minutes, but this will do. Next, we look at Derek collects quarters that have the names of the 50 U.S. states on them. He has collected 13 different state quarters in 2.25 months. At this rate, how long will it take him to collect all 50? I actually did this growing up. I think I had about 49 of the 50 states. Didn't have Alaska, unfortunately. Anyways, that's a moot point. So here we're looking at 13 different states in 2.25 months. So we're going to set that equal to or proportionate to 50 states, right? Because that's what we're aiming for. And here, how many months is that going to take us? That's the question. So we're going to put an X down here, right? We got to make sure our months are with our months. And so we could do the cross multiplying, but since it's like at this rate, it only seems fitting to find the unit rate. So we're going to do that nice and small over here. We're going to have 13 over 2.25 is equal to something over 1. So here I had to divide 2.25 by 2.25 to get to 1. So I'm going to do the same thing on top. And 13 divided by 2.25 is 5.7 repeating. And so what that's telling me is that 5.7 repeating states per month. So I'm going to go ahead and take this unit rate and put it right where I have that 13 over 2.25. So I could have done that cross multiplying like I did up top, but here I'm going with the unit rate, which is 5.7 repeating over 1. So now I can cross multiply. Here I'm going to do 50 times 1, which gives me 50. And then I know I'm going to have to divide it by my 5.7 to get x by itself. And that gives me 8.77. So that's how many months it's going to take Derek to collect all 50 states. Good luck to you, Derek. Hopefully you can get Alaska. Fulfill my dreams that I never accomplished. All right. Learning target number 5. I can find the unit rate for a proportional relationship. All right, so this is basically what we had just done. Going to get 800 over 12 here, and that's going to give us our answer. Nice and simple, but we always got to have the reasoning behind it. So with our unit rate, we're going to want our time on the bottom. In this case, is going to be minutes, and we want that to just be 1. Right now, we have it as 12 minutes. And so what do we need to do to get from 12 to 1? We need to divide by 12. And so when we have our 800 words on top, we're also going to divide by 12. And 800 divided by 12 is 66.6 repeating. First and 10, Wisconsin. Nice. So now we're moving on to the next one. Travel 357 miles in 5 hours. We'll do the proportion again. I know you guys don't want to, but we're going to. So we have our distance on top, our y or dependent variable, over our hours that we're driving, which is going to be 5. We want to get this over 1, which we want to have per hour, and so we need to do 357 divided by 5, 71.4 miles per hour. Look at that. The words are already here. We don't even need to label. And then the final one here, we have 3,500 over 6. And that is 583.3, which is calories per serving. But hey, look at these. I mean, these are all super, super useful things. Like a lot of times I want to know how fast I can read or type. So that's going to be my words per minute. I like to know how many miles per hour, especially how many miles per gallon I'm getting. So that's also super important. Calories per serving, you betcha. Got to watch my figure. So, I mean, this is why I love this unit so much, just because we use proportions every single day. Especially here, we're looking at what is the better buy, right? I don't want to overpay. What's the better deal here? So I have 12 bars of soap for $10. So the tricky part here might be like, okay, which one's going on top? Which one's going on bottom? Well, let's think about our y over x. That's how we write things. And so what is our y or our dependent variable? Well, that's going to be our dollar amount, because our dollar amount, how much we're spending, is going to depend on the bars of soap that we buy, right? You can think about independent variable, the I in independent, that's going to be what I control. So this is going to be our x. So if we have it as y over x, we're going to have the 10 over the 12. Don't know how I did that. There we go. 10 over 12. Oh, come on. Thank you. And so that's going to boil down to, see, 10 divided by 12. 0.83 dollars, or simply 83 cents per bar of soap. And then 5 bars of soap for $4. So again, the $4 is going to go on top. That's our dependent variable. Depends on the bars of soap we buy. So here, if we're going to find our unit rate, we're going to do 4 divided by 5, and that gives us 80 cents. So which one is the cheaper buy, the better buy? I don't want to spend more, so I want the lower amount. That's going to be the 5 bars of soap for $4. Nice. Next, we're looking at 97.45 over 5 gallons. We want to get this for just 1 gallon, our unit rate, just like we did above. So we're going to divide by 5 and divide by 5. So what does that give us? 97.45 divided by 5 gives us $19.49 per gallon. And next we have, oh, this one's nice and easy. It's already done for us. $21.95 per 1 gallon. So the cheaper buy, or the better buy, is going to be my 5-gallon bucket. Next we have 50 head of cattle. Oof, that doesn't sound good. For $24,500. So we're going to divide both by 50 to get 1 on the bottom. Our unit rate for 1 head of cattle just doesn't sound good. A head of cattle. 2, 4, 5, 6, 7. Oh wait, I don't need a calculator for this. Let's see. 50 goes into 24. 4 times plus 4. I think it's 490. Yeah, I think that's right. Sorry if I'm wrong. Trying to be trying to use my smarticle particles here. Okay. Next we have 18,870 over 37. So here I do have to use one. Okay. Divide by 37. 510 for 1 head. So the cheaper buy, or the better buy, is going to be that F490. In case you're looking to buy a head of cattle. All right, now we're looking at diamond problems. So this top number, that's going to be our product from what I remember. And then that bottom number, that is going to be our sum. So now we got to figure out the missing 2 numbers to complete this little equation here. So let's see what 2 numbers add together to make 8 that multiply to 8 that add to make 6. Now let's see, 4 and 2 gives me 8. 4 plus 2 gives me 6. Cool, you guys got the idea. Awesome. All right, so this one, again, we want the product up here. We want the sum down here. So -2 times 6, that's going to give me -12. And then -2 plus 6, it's going to give me +4. And then here we have 4 times what gives me -28. Well, I'm going to need a negative number, and it's going to be 7, -7. And then 4 plus -7, otherwise known as 4 minus 7, will give me -3. Awesome sauce. Next, we have plotting the points. So I'm going to take a look at A in green. We're going to first go with our X, right? It's going to be X before Y. You can think about that because of the alphabet. X comes before Y. You can also think about it in terms of, if you're curious why I'm single, you would have to ask my ex why. A little bit of late night math humor for you. So here I'm going to go nowhere on my X, not going to the right at all or the left, but I am going to go down 1, 2, 3, 4, 5, 6. That's going to be my first point, A. And then we're going to go to B. Well, I don't want subtitles. I want my different color. Nice. And we're going to go over 1, 2. We're going to go up 1. So that's going to be my second point. Oh, you can't even see my first point. There it is. I'm going to do this next one in orange because I like orange. So we're going to go 1, 2, 3. And then we're going to go up 2. So we went back 3, up 2. That's going to be C. And then we're going to do D here in blue. We're going to go 1, 2, 3, 4, 5 in the negative direction. And we're not going to go anywhere down or up. So, looking good, I'd say. All right, now we're going to actually take a look at where these are already plotted. Here we are 1, 2, 3, 4 over. So that's going to be 4 for my X in the positive direction. And then how many up? Well, it's going to be 1, 2, 3 up. Again, in the positive direction. And then B. There's B. So B, we had to go 1, 2 in the negative direction. And then we had to go down 1, 2, 3. Again, in the negative direction. So then we're going to look at our final point, O. O stands for what? Origin, right there, 0, 0. How clever. Little smiley face here too for you. All right, learning target 8, I can recognize and extend patterns. Draw figures 0 and 5 above. Oh boy, these ones always give me a little bit of trouble. So this is figure 1, so if I have figure 0, I just think it's going to be blank. There's going to be nothing. So I can cross off this first part. And then 5 above, let's see. So here's figure 4. And let's see if I can figure out the pattern. So here we have 1. And then we go with these two new guys. And then we have these 4 new guys. If I had to guess, we're probably going to have, what, 6 new guys? Yeah, 6 new guys. Take your time on these. Sometimes they take a while. So here we increase by 2 because we're going from 1 to 3. And then we increase by, let's see, 1, 2, 3, 4, 5, 6, 7. Increase by 4. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're increasing by 6. Okay, so it looks like we are increasing by 2 each time from the first figure, right? Plus 2, plus 4, plus 6. But as far as the numbers we have here, 1, 3, 7, 13, it's not really a clear pattern. But I can go ahead and draw the 5th one since I know we're going to increase by 8. So here we go. All right, so I'm going to draw my new pieces here. Going up by 1 on the top, it looks like. And it looks like we're adding 2 here. So 1, 2. And then we're going up 1, 2. on the next row. It looks like we're going to have a new row. Let's see, how many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's see, there's one more here. There we go. So like we're got two more here, two more here, two more here. That seems like that's where the 2 is coming from each time. And so we're going to have 21 for figure 5. And here's our picture. It would take me forever to draw all those out. Describe how the pattern is growing, increasing by 2 more than it did the last time. And that last part is so important to put in here, I think, because if we said increasing by 2, well, that wouldn't be accurate because we're going from 3 to 7 and from 7 to 13. Like, we're increasing by a lot more than that, but we are increasing by 2 more than we did previously. How many tiles would there be in figure 10? Let's see, if we're increasing by 2 more each time, we're at figure 21 for figure 5. And then we're going to increase by 10. And then we're going to increase by 12. So this would be 6. This would be figure 7. Increase by 14 for figure 8. Increase by 16 for figure 9. And finally increase by 18 to get to figure 10. Okay, now I got to add all this to 21. So I'm going to do 21 plus all of this that follows. My next 5 figures. So 21 plus 10 plus 12 plus 14 plus 16 plus 18. 91 tiles in figure 10. How do I know? Because I showed my work over here. Showed work increases by 2 more than the previous increase. That's what I wanted to say earlier. This was tricky, but we did it. We did it. All right, next we're looking at learning target 9. I can find the area and perimeter of rectangles. Cool. This is a little break from that hard stuff. So here we're looking at Susan's apartment. Pretty nice place. All measurements are shown in feet. All right, so 10 by 10, this is feet. 10 by 30, feet. Don't forget it. The dimensions of the bedroom are 10 by 30. So here's our bedroom, and we have 10 feet by 30 feet. The dimensions of the kitchen are 10 feet by 10 feet. So now we can answer the questions based off of this information we've been given. Find the area of the living room. All right, so here is our living room. And since it's 10 feet over there for the kitchen side length, then this side length is going to be 10 feet as well. And then the length is going to be 30 feet, just like the base of the bedroom. So we would just do 10 feet multiplied by 30 feet. And here we can do 1 times 3 gives us 3. And then we have 2 zeros. So we can put 2 zeros afterwards. And that'd be 300 feet. And we could put squared, or what I like to do, what a lot of you probably like to do, is just put a little 2 above that foot. Feet squared. All right, next, find the area of the entire apartment. Okay, so here we have 10 plus 10. That's going to be 20 feet. Then we have 30 plus 10, right? We have 30 up here, and then we know this is going to be 10 because down here is 10. So we have 40 feet. So we have 20 feet multiplied by 40 feet. And again, 2 times 4 is 8. 0 and another 0, 2 zeros. So we just throw those after the 8. Little trick for you there. It's going to be 800 feet squared. Find the perimeter. So perimeter, that's not going to be square, right? It's just a straight length of the entire kitchen. So maybe we want to put a little baseboard around the kitchen, or whatever that bottom part of the paneling is. You know what I mean? Like where the paneling meets the floor. Sometimes you have that little board thing. I don't know what it's called. Okay, the perimeter of the entire kitchen. So we said that this here is 20 feet for this entire side. Oh, wait, no, we just want the kitchen. Just want the kitchen. What are you doing? So the kitchen, we said, is 10 by 10. So going all the way around is going to be a square. So 10 plus 10 plus 10 plus 10. 4 times 10 equals 40 feet. Don't care about what's on the inside. Find the perimeter of the entire apartment. This is where that comes into play. So we had 40 for our side, and then we had 20. Oh, this was 20. This was 40. So we're going to do 20 times 2 plus 40 times 2. So that's going to be 40 plus 80, which will be 120 feet. All right, and that's just going to be all around here in my beautiful orange. I am quite the artiste. All right, now we're looking at learning target 10. I can create and interpret statistical displays. So here's our statistical display. It's also known as a data set. And so here I'm just going to go ahead and start by lining it up from least to greatest because that'll help out big time. There's 39. And then it looks like 52. 54. 83. 84. 75. 96. And 105. All right, nice. So now we want to create a box plot. Now, a box plot is that thing where we have our data split into fourths, right? We have 25% here, 25% here, 25% here, and 25% data percent here. And so what we're doing is we want to start out with a median, the middle of our data, and then we also want to have another median, which should be right here, and finally another median. So we're finding 3 medians here. So remember, the median is going to be our middle number. Kind of sounds similar. Medial, medium, middle. So here we're going to go 39, 105, 52, 96, 54, 75. So here we have 83 and 84 as our final 2 left. The median between these two, what's in between them, will be 83.5. So when we draw our box plot, I know that the middle is going to be 83.5. And then let's take a look at the median for in between 84 and 105. So here I'm taking a look between 84 and 105. We're going to have 96 and 75 as our two middle numbers there. So if we add 75 to 96, that's going to be 171. And if I divide that by 2, let's see, that would be 80, 85.5. This is going to be another median of ours. So 85.5. And then we got to find this side's median, which is going to be, see, cross off 83, cross off 39. We're left with 52 and 54. So it's going to be what's between those, and that would be 53. So here we'd have 53. So that's going to be what's inside of our box. That's called our interquartile range. All right, so far we have our median of 83.5. We have our first quartile of 53. And then we have, I'm just going to label this Q1. This would be Q2. This would be Q3. This is going to be 85.5. Then we're going to have our max and our min. So we're going to extend this even further out. Actually, farther out would be the correct English. And that's going to be our highest number, should be 105. And our lowest number, 39. So that'd be our max of 105. And our min of 39. And I mean, this isn't drawn to scale. Typically, we'd have, a scale that would be very nice and neat. And it might be like 30, 40, 50, 60, and so on. And we match up our box plot with it. But just for now, we're going to go with what I have here. So again, this is your median of the whole data. This is your median between your median for the whole data and your lowest number. And then this is your median for the data between your median and your highest number. All right, now we're looking at mean, median, mode, and range. So let's look at what this means. What does mean mean? What do you mean? So that's going to be our average, right? Justin Bieber's average. And so here we have 7, 8, 9, 10, 13, 14, 16. What do you mean? We need to add these all together is what I mean. And so if we do that, we're going to get 7 plus 8 plus 9 plus 10 plus 13 plus 14 plus 16, 77. And then divide that by however many numbers we have here, which looks like 7. So our mean should be 11. Our median is going to be if we cross off those numbers, starting from farthest left, farthest right. So we're left with 10 in the middle. Find the mode. That's the number that we see the most. We do not see a number here more than once, so not applicable. Find the range. That's going to be the largest number minus the smallest number, so 16 minus 7. Cool. That was nice and quick. And that does it, folks. Can you believe we're already done? Wow, that took no time. Here we go. Nice job, guys. Thank you.